In this video, we will cover review exercise 4 at the end of tutorial 4 on pages 453 through 458 in the text. I highly recommend that you first take significant time looking this drawing over and familiarizing yourself with the geometric elements and the way they are dimensioned, so that when following along with this video, you will have a sense of the logic behind it. To begin, however, I'm going to build the most obvious element, which is the rectangle. It's 9 by 6.5. That's a negative 6.5. You can't tell the origin on the print, but it reveals itself in the subsequent sketches on page 454. So I'm going to place that in the lower right corner of the origin and apply it. I have a center line as well. I'm going to change my line type to center line, and I'm going to do create parallel lines and place that center line at 5.75 off of this line. So 5.75, select a line, select the direction, and there's my center line. I'll be using that quite a bit. Go back to my regular line type. Go back to my center line, apply it first, then change my line type. Back to the regular line type. Now I can start putting in some of the parallel lines that will help me with my geometry. One of the main things I see is that there's a lot of things dimensioned off the bottom of the part cavity, if you will, and that line is 2.75 off the bottom. So I'm going to put that one in. Create line parallel. Put in my 2.75, enter. Select a line. Indicate the direction. And that line will represent the bottom of my part cavity. Both of these have a lot of dimensions originating from them. So that's a good thing to get going. Now I'm going to start working on that profile and check out of that. And in looking at it, I can see the most obvious feature is that plateau at that notch area, and that plateau sits at 1.650 off the bottom of the part. So I'm going to go back to parallel lines, type in my dimension off the print, 1.65, enter, select a line and a direction. And there's the bottom of my plateau there. I also have a dimension of 0.5 that depicts the intersection of the slant that's coming in, that angled line. I'm going to put that one in as well. Accept that. Put in 0.5. The 0.5 is off of here as it's dimensioned. I'm going to accept that one. And then I've got some vertical lines to put in as well that will handle intersections off of some of the angled lines in that area. One of them is at 1.15 off the center line. So I hit enter, select a line and a direction. Accept that. There's also one at 1.5 off the center line. And that also reveals an intersection of some of these angles that we're going to be putting in. I'm going to check out of that. I'm going to go to line endpoint and begin working on those such angles. The 35-degree angle actually originates from this point, and it is at 90 plus 35 for 125, enter. And lo and behold, it follows right along that intersection that we've got. So we had redundant information there, but it's okay because it serves as a verification that we are on the right track. And it also saves me a trim because I'm just going to drop it in at that intersection. I can also work on the 45-degree. I apply that. The 45 is actually 45. Enter. It originates right at this intersection, and my 45 went away. I'll have to lock it back in there. I'll drop it in near the top and apply that. I'm also going to put in the the horizontal line that this cuts off at. Looking at my drawing, it looks like it cuts off at 3.475. So I'm going to check out of that and go back to parallel lines and put in my 3.475 dimension, and that comes off this bottom and it's in that direction. Now I can trim my 45-degree angle to that as well. Get my scissors out. I have it in the one element, so I'm saying I'll keep that to there, and it's trimmed. I don't think there's anything more to trim at this point, but I can delete some of this. This one I'm finished with. This one I'm finished with. The plateau I'm going to keep because I'm still going to use that one, so I'll hit my delete button or my eraser and get rid of those. I can trim the plateau now. My scissors. I want to keep the plateau to that line. I no longer need this or this as well, so we'll delete those. And I've got part of my profile now. It looks like I don't have much to work with working my way down, so I'll go back to the bottom where I can see a lot of dimensions and intersections and even an angle and work my way back up. So starting with my bottom of part at 0.275 off the rectangle, I have some more parallel lines. One of them is at 250 and one is at 950, and these are intersections for those angles at the bottom. From here, 250, apply, 95, enter. From the bottom, 950, apply. And my vertical lines for these angles and intersections are 2.245, and that's coming off the center, and 2.5. I forgot to apply it, so now I'm going to apply the 2.5. I'm going to go back and put in the 2.245. Pick a line, pick an offset direction. There we go. So I've got those lines put in, and now I can drop in some of the angles at the lower part of the profile. Accept that. Go back to my line endpoint. I see I've got one at 10 degrees off of this intersection, so I'll put that in. 10 degrees is actually 90 plus 100 in this instance, so there's my 10, and I'll just place it randomly, accept it. I have another angle that I really don't know what it is, but I have the intersection point, so it doesn't matter, so I'll place it there and there, and accept those lines. Now I can delete a few more. I don't need that one, or that one, or that one. So that'll help clean it up a little bit. If you just roll your mouse wheel, it'll repaint, or you can hit repaint if you'd like. Okay, so now I'm going to do a little bit of trimming. I'm going to get my scissors out. I'm just going to use the one entity. I'm going to trim my plateau to this angle, this line to the plateau. I need this little leg right here to this angle, and the little leg to this horizontal line. Check out of that. Now I can delete this line, and it's time to put my fillets in. So I go to fillet, 1.25, got one here and here, got one here and here. I can accept those, and I've got a 0.0625 fillet right here. And that is my profile contour ready for mirror imaging. So I go to X-Form, Mirror, Slide a box around all of that and selection. I want to select a line, that one, and there we have it. X out of that, clear colors. Now we've got something to start preparing our handle geometry for. The first part of the handle geometry I'd like to create is the plateau as well. It's always the low-hanging fruit. So I need parallel line. The dimension from the print is 1.35. Select a line, indicate direction, and there's my handle plateau. I've also got an intersection down at the lower left-hand corner I can use for things, different geometric elements. So I'm going to stay in the parallel command and pick a offset direction of 0.75. Pick a line and a direction, except that one. I've also got an offset direction of 6 from the top. So I'll pick a line and a direction there, and this gives me an intersection point that I'll be using later. Check out of that. I've got a couple of arcs I can use. They are actually dimensioned as center points, so I'm going to go to create circle center point. The first one has a radius of 2.5. Enter. I'm going to go to my fast point and just put these coordinates in. It's 4.5, comma, 0.625. Enter, and that makes the, from our plateau, sloping down handle there. I'm going to accept that one. I'm going to do another one. The radius is 5.5. And the coordinates are 6.75, comma, and negative 4.375. Because they're coordinates and not parallel lines with directions, I need to use the negative off the origin. Hit enter. Now we can trim those circles up a little bit to make it look better. Go to my scissors. Trim divide to me is the best one for circles. All I want to keep is this piece and this piece and this piece of the plateau, so everything else can go away. So trim divide, pick that one. We don't need any of those pieces. This is the only one we need. Take that one out as well. And for this circle, it's the outside of the handle, so we just need that one. I can also use trim divide to clean up this line because I only need that part of my plateau. So these are the actual parts of my drive surfaces, if you will, for machining. I've also got a radius at the bottom of the handle. It's tangent to this point and this radius, so I'm going to use the create arc tangent. The radius is right on the part. It's 9.675. Enter. Select entity it's tangent to. It's tangent to this arc, and the through point is that, and this is the one we want. I'll take that. Now I can trim. So I go get my scissors out, and I'm going to use the trim one entity, and I'm just going to say select the entity to trim and extend. Basically what I'm saying is I want to keep this entity to here and remove that tail. Check out of that, select and delete these lines. They are no longer needed. And now we can put our fillets in. Create fillet. These are 250s. There and there, there and there. Those look good, and we are ready to do our offset contour. So we go to X-form, offset contour, pick this chain, check. The print has us at 0.4, enter, and our direction is reversed, and that's what we need. Clear colors. First instinct is to trim this, but we don't want to do that. We'll let the fillet that we're going to create down the road between the two surfaces handle the fillet. But before we can create those surfaces, we need a contour. So I'm going to change views, I should say construction planes, and we want to work in the front. We see this did change, and I'm going to roll up on this. Per the drawing, I need an arc radius of 0.2 down here. So before I do that, I want to create a line end point. Make sure you snap to the end of this and the end of that. That looks good. And I also need a parallel line. Because this is done on an angle instead of straight parallel with the front, we've got to control it. Whenever I try to use the 3-point method with the center point, it would draw the radius parallel instead of on this angle. So the way to handle that is to create a parallel line at the radius height, which is 0.2. Pick a line, pick an offset direction, and that's what we need. Now, when I put my arc in, it will follow that angle, but instead of an arc endpoint with the radius, which would be this one, I need the arc 3 points, and I'm going to use the center of this parallel line as my radius point. So it says enter the first point is this, enter the second point is snap to the center of this, and the third point is snap to the end of that, and that's what we need. We need that profile on an angle. At this time we can delete these for now and fit the job. Now we can create our swept surface. I'm going to change colors because I'm doing a surface. And it looks as though I'm back in top view, but I'm going to make sure I'm in top view. And also make sure it's in up here. I don't know why those aren't consistent, but I just want to make sure I'm doing everything in the correct construction plane. So now the swept surface, create surface, swept. We're instructed to use 2 rails. Sweep surface, define the across contour, which is the arc we just created. I'm going to use single and pick that. Counterclockwise looks okay. It's worked for us last time. So I'm going to check out of that, and now it says sweep surface, define along contours. These are our rails. They're partial chains from here to here and from here to here, and there's our swept surface. We can apply that and check out of everything. That looks good. Like I said, when we fill it to this revolved surface, it will clean itself up. Before we do the revolved surface, I'm going to change a color so that I can have contrast between the two. Create, surface, revolved. It says to pick a chain, a profile curve. Take that one, check it, select axis of rotation, that's our center line. We need to use 180 degrees worth of this, and it's in the reverse, and that's the revolved surface we want. We can check out of that. Now it's time to work on our fillets. I'm going to change colors again. I'm going to pick this green. Create, surface, fillet to surfaces. Select the first set of surfaces. We are instructed to go from the revolved side first. 2, 3, 4, all 5 of these are involved with the fillet to the handle. End selection, that's our first set. Our second set is the handle right here. End selection. I also learned that it helps to pick from the inside of the part instead of flipping it around and trying to work from the outside. I've had a lot of fits doing that. So these fillet commands are really particular. And you have to really think about what the machine's thinking when you're doing them. This fillet is at point 1. We need to enable trim to take care of this piece sticking through here. I am not going to enable the extend surfaces as we are instructed to do on page 455. It seemed to cause a lot of problems, so I'm going to just skip that. And I'm going to do the auto preview. It looks good already. It's been trimmed on the inside, and it's all the way around, encompassing those 5 revolved surfaces. So I got lucky, and maybe that's because I practiced, because a lot of times this doesn't work and you have to go back and look at your arrows and by flipping normal. Sometimes you have to go back to wireframe and look at your arrows, make sure they're all pointing the right way in terms of the logic of the fillet. But we did okay there. I'll just hit enter and check out of that. So there's my fillet. We're next instructed to create a flat boundary surface down at the end of this handle. I'm going to flip my color to red. I'm going to keep green for fillets. We need a line here to make a solid chain all the way around. So I just do create line endpoint and pick the end of that and the end of that, check out of that. Now I can go to create surface, flat boundary, pick a chain. I'm going to reverse that. Now it says I've reached a branch point, so select the next branch. So what that's saying is that we don't have a closed loop, but I just need to pick the next branch, which is this arc. And now it's saying we went in here and we came out here, so that's closed. Check out of that. Surface looks good. I'm going to check it. And if you mouse wheel or repaint, it'll clean everything up. Now I'm going to put a fillet in there. Back to my fillet green. This fillet is 0.0325, a little more than a 32nd. I'm not sure why they came up with that number. Nevertheless, we're going to create another fillet surface, so we go to surface, fillet, 2 surfaces. I'm going to try to get inside of this thing. Which one to pick first? I'm going to try to pick the sweep first, just to see what happens. End selection, second set of surfaces, I'll click the flat boundary. End selection, my radius is 0.0325. Auto preview, no fillets found, which means I have to go up and flip my normal. I'm going to put it on wireframe, and I can see that this surface needs reversed. We need to go in and up, so that should do it. Enter, and it did. Solid just to make sure. Looks good. We'll check out of that. Now I went to my top view and fit because it's time to put in the draft surfaces. I'm going to make those blue. Before we can put the draft surfaces in, I need a couple of lines, so I'm going to go to line endpoint, snap to this intersection, and come off of this part a ways. I'm going to pick a distance of just 5 inches, so that's plenty. My angle is 8 degrees on my drawing, so it's 180 plus 8 for 188. Hit enter, and we've got our line. If I just wheel this, it'll repaint. I'm going to apply that, and I'm going to put another line in. Just call this one horizontal, and I'll put it from here to here, and then I'll place it on its coordinate after I'm finished. I look at my drawing and I see that my distance from the actual origin here is 6.5 minus 2.75, so my distance is negative 3.75. We need the negative in here because we're not doing a parallel distance, we're doing an actual coordinate number. So put that in, enter, and there it goes. I'm going to check out of that, and I'm going to extend this one past a little bit too, just like we did on tutorial 4. Get out my scissors. Let's do a 0.2 and pick the line up at this area, and there we have that. Now we can create our draft surfaces from there. Create, surface, draft, chain, pick this chain, check it, okay. Per the instructions on page 455, we need 3 inches and 3 degrees, enter, and we clearly need to do some flipping here. Definitely in the direction. And if I go to the front view, I can verify that in fact that angle is correct as well. I'm going to apply that, go back to isometric, pick this chain, check. It looks like the direction's correct, but the angle needs flipped. I'll just flip that angle, double check it with my front view, and there are the draft surfaces that I need. Check out of that. I'm going to extend the revolved surfaces like we did in tutorial 4, just because I think they do that in case your subsequent fillets come out backwards. At least you can visually see that if you've got the extra distance to play with. Otherwise it may throw you something that you can't decipher as well visually. I'm just speculating on that, but it only takes a second to do it, so I'm going to do it. And ultimately it's going to be trimmed anyway once we get everything set correctly. So create surface, extend, and I simply click that surface, free mouse up, and click. Click this surface, free mouse down, and click. And as you can see, they've been extended. Check out of that. And now I'm ready to put in my fillets against the revolved and draft surfaces at the top and bottom. Go to my fillet green color. I'm going to go back to isometric, and I'm going to work the top first. Again, I'm working from the inside. I tried working from the outside and was very unsuccessful. I've been testing various logic in terms of selection process and order, and I'm still not getting much consistency. So again, this fillet command is very temperamental and very automatic, and you have to try to get into the mind of the software. But some of the things I have figured out is that you do it from the inside, if that's where your fillet's going to be. Create surface, fillet, 2 surfaces. Select the first set of surfaces is up here. I'm going to pick the revolved surface first, end selection, and pick the draft surface and end selection. This fillet is 0.0625. We need to trim, obviously, and auto preview, and it went entirely backwards. And see, that extra trim, or that extra extension, gave us the ability to actually show us visually that that was the case. So what I see from here is I needed to go and switch both of my arrows. I usually only recommend switching one at a time, but in this case, since there are only two and everything's completely reversed, I'm going to take a chance and switch them both. Go to wireframe. This arrow talks about the draft surface. So I pick the draft surface. This one's the revolved. I pick the revolved. I found that if you pick the surfaces as opposed to the arrow handles, it works a little better. Enter. And I think we got it. I'm going to color it just to make sure. And that's what we want. I'll apply that. And now I'm going to do the bottom one. So I need to get up inside this bottom one. And I'm prompted to select the first set of surfaces. I'm going to pick the revolve surface first and selection. Then I'm going to pick the draft surface and selection. My radius size is correct. Trim is in. Auto preview. This is where we want to back it up. And it's reversed. But only the revolved arrow looks to be reversed. So I'm going to try to straighten that one out by doing flip normal, going to my wireframe and trying to pick on the revolved surface and flip that arrow. I think I have. Enter, shade, giving me troubles. Try it again. And there we have it. I had to flip the arrows around and just play with them, and I normally would edit this out of my video, but I think this was a worthwhile adventure. So I'm going to check out of this, shade it, isometric and fit, and show you that sometimes you just got to play with your arrows to get things right. Now that all of our part geometry is intact and ready to go, we can start preparing to machine. First thing we have to do, however, is to move all surfaces and outside rectangle onto level 2. So I'm going to go to my levels, and I'm going to call level 1 my wireframe geometry. Enter. Then I'm going to make a level 2. Enter, and I'm going to call it toolpath geometry. Enter, and I'm going to make it, which it already is, my working level, and you can see that if you hover right down here. Now I want to move all the surfaces onto level 2 and the outside rectangle, because these are things I'm going to use for the purpose of machining. So pick your QM surfaces and the rectangle by pushing the shift key down and picking that. You can see it was all selected. Now I right click on level 2 there. I want to move everything to level 2, so we just check out of that, and it looks like it has been done. We can go into our levels and make sure. Yes, from level 1 to level 2, more than half of the elements had shifted. While I'm in here, I'm going to turn off the visibility of level 1. And now we've got some things that we can machine. So now we can create the silhouette boundary. Create silhouette boundary. Pick the Quick Mask Surfaces button. And press enter. Those settings are good. Check out of that. And we've got our silhouette boundary. Now all we need is a flat boundary surface. I'm going to change colors for that. Pick the orange. And I just go up to create. Surface. Flat boundary. And here I'm prompted to select flat boundary 1. I'm going to pick the rectangle. Now flat boundary 2 will be this entire silhouette. Check out of that. Say OK. And we've got our flat boundary surface. At this point we want to save the file and start setting up our machine and our stock. We go to Machine Type, Mill, Default Mill. We want to set up our tool settings the same way we always do. This is the 8th job we've done. Check all these boxes. And then go to Stock Setup. Here we want to use the bounding box and for stock, so I'm just going to check that, and our stock depth is 2.75. Enter. Our origin is up in this upper left corner and it's represented by 0, 0, 0. So now we have our stock. These couple extra tenths don't really mean anything. And we are ready to start roughing out the part. So on page 457 I am instructed to use Surface High Speed Toolpath. So I'm going to go to Toolpaths, Surface High Speed, Area, Opti Area, That's what I call my file. I want you to put your name in yours as well. And now I'm going to select all the surfaces. So I just go to my Quick Mask, Enter, or in Selection. For a containment boundary, I want the silhouette. I just want to reverse it. Check out of that. Check. This is Opti Area, the tool. We need a 1/2 inch bowl end mill with a 0.0625 radius. I'm going to go to the library. Bowl is up. I'm going to pick equal to the 1/2 inches. There's my 1/2 bowls. I need the 0.625, which would be this one. And I'm going to type rough out the part. Holder's okay. Now we go to cut parameters. My step over, we're instructed to use 33.75%. Step down is 400%. Enable step up and set it to 10, which it is. Stock to leave on walls and floors is 20. And tool containment, we're going to compensate to the inside. The transition entry is helix only. And the linking parameters, minimum vertical retract, and the remaining defaults. And we've got that operation. It may take a minute to generate. It still looks dirty over here. And there it goes. I'm going to verify it. put this on as fast as it'll go. It's taking anything that geometrically can handle the size of that end mill. Very good. Now we're going to clean up this remaining surface with a OptiRest, which I interpret as the rest of the material, even though it's not finished. Toolpaths, surface high speed, OptiRest. OK. Again, quick mask, end selection or enter. Containment boundary will be the silhouette. We'll pick that. Check out. OptiRest. The tool is a 1/4 inch bowl with a 0.625 radius. Select a library tool. The bowls are on. I just put a 1/4. Check through the bowls. I need the 0.0625 radius, which is this one. It's just rounded. Holder's the same. Cut parameters. Step over 19%. Step down 800%. This is of the diameter of the cutter. And then they calculate it next to it. Enable step up and put it at 20. Stock on walls and floors is 0.02. I just put one in and they both take. Use remaining stock as computed. The tool containment is to the inside. Transitions are helix, linking parameters are minimum, vertical retract, and the defaults. I will select both of these, select all, once this is done generating. You can see it's not generating because it's still dirty right here. There's a lot of lines of code there to go through. And there it is. I've selected all. Now I'm going to verify it. I have it on full speed. I guess it's thinking this is the only part of this entire sweep that can handle the diameter of the cutter. I'm not sure why. It probably had to do with some of the parameters we set. But that looks good. Now we're back to our part from our animation window, and looking on page 458, we are instructed to set up a stock model. Toolpath, stock model. The stock definition is stock after roughing. We are in the top view. It is rectangular, and to fill all this out, since it's the same as the previous stock arrangement, I just click stock setup. Source operations are both of these operations. Hit the control key, and we've got them both enabled. It's still generating. because it will fill out this actual wireframe when it's complete, at which time we will right click in the Operations Manager and do an alternate T to hide it again. Right click here, alternate T, and that got rid of it. So now we're instructed to finish the cavity areas using Surface High-Speed Hybrid Toolpath. Since my check surfaces and my drive surfaces are all the same as the other operations, I'm just going to first click on that one to get the green check, then right click, copy, and then paste it near my bookmark. And there it is. So all the surfaces are the same. Now I just go in and change the parameters. So my selection's already done. This happens to be a hybrid, so I have to do finish, hybrid. The tool is a 1/4 inch ball end mill. Go to the library. Here's a 1/4 inch ball. I'll pick that. I'm going to finish cavity areas. For the verbiage in my program. The holder's okay. Cut parameters, the step down is 0.02. The limiting angle is 45, and the step over is 0.02. Transitions is the same, tangential ramp. Also, cutter comp was supposed to be to the inside and no stock on walls and floors. So I had to go back to cut parameters and fix those because I'm working down the list. Then linking parameters is just minimum vertical retract and everything's the same. So there it is. Now I need to regenerate the dirty operation because it's dirty. And there it is. I'm going to verify it. Full speed ahead. I think that looks pretty good. Get out of that window, and we need to do one more. This time I'm going to right click on here. I'm going to copy this one, paste it, and go adjust the parameters on this one. This is going to be a scallop. The tool, I need to make a special tool because we're so deep. So I'm going to right click for options here, create a new tool. It's going to be an end mill. Next. Cutting diameter is 0.125. I need an overall length of 4. Cutting length is 1. The corner type is a full radius. And everything else looks good. Finish. There's my new tool. Now I can pick it. It's tool number 4. We're going to finish remaining cavity areas that were left behind from the 1/4 inch end mill. Basically pick out the corners. cut parameters on this are obviously leave no stock, inside cutter comp, step over is 0.02, I'm sorry, 0.02, and everything else is about the same. I'll have to regenerate it because it was an edited operation from before. It's regenerating, it's still dirty. I can also alternate T some of that stuff away. Okay, so let's verify. This is just the final operation. I just want to make sure it doesn't wreck. I was having issues with the last few instructions, enable trim to stock and enable roughing tool and set the diameter. I kept wrecking into the side of the part, so I just didn't use those. That operation looks good. Now I'm going to run the entire job. Select everything and verify. I'm going to run it as fast as I can. So we did the surface high-speed opti area, now we're doing the opti rest toolpath. Then we're going to go into the hybrid for finishing, and then the scallop to pick out the rest. And our end mills get smaller every time. And that's the efficient way to do it, because you want to take out as much stock as possible with the biggest end mills. You'd be forever trying to do this whole job with a little end mill. So that's the thinking behind it. And then the MasterCam is so intuitive, it knows what's there and what's not there and what's left behind and what needs to happen. So it's very automatic, and that's part of the reason that it can be so temperamental. I'm going to flip this up a little bit. Just make sure everything's looking good. Had to get out that special long tool because my holder crashed into the side without it, which makes sense. We're pretty deep here picking this out. Didn't do it with the bigger end mill because they're usually a little bit longer. But a long skinny end mill is usually something special, so we took care of it. You can buy any tool you want, you can have it made. There's plenty of vendors out there who will make things for you. So there's our part. That's exactly what we need to do, and good luck. This one was a beast.